Stronger signals. Let's start with something that isn't very well known in everyday life: weather models. These are the computer simulations that meteorologists use to predict what's coming. Thanks to these, you can easily check your phone and know whether you'll need to bring a raincoat the next day. Lately, they've been showing something interesting: more snow, a lot more snow. These simulations aren't perfect. They disagree all the time. One says rain, another says snow, and a third says partly cloudy. But when many of them start converging on the same forecast, that's a strong signal. It means the atmosphere is setting up in a way that's predictable and consistent. What we're seeing these days is something called ensemble clustering. Instead of just one simulation run predicting heavy snow, dozens of ensemble members are all pointing in the same direction. Think of it like this: if one person tells you it's going to snow, you might be skeptical. But if 10 people, all looking at different sources, tell you the same thing, you start paying attention. That's where we are right now. Cold meets moisture. Now let's talk about timing. Snowfall isn't just about having cold air or having moisture. It's about having both at the same time. And that's exactly what's happening. Cold air has been sitting over large parts of North America for weeks, almost like it's just waiting. Meanwhile, moisture-rich systems are moving in from the Atlantic and the Gulf of Mexico. When these two meet, the conditions are perfect for snow. This setup is often referred to as a phase-locking scenario. The cold air almost stubbornly doesn't move out before the moisture arrives. As a result, they overlap. As this buildup continues, it eventually becomes unavoidable, and massive amounts of snow can suddenly fall all at once. Arctic cold supply. If you want to understand why snowfall totals are rising, you need to look north, way north. Canada is sitting on a massive reservoir of Arctic air right now. This isn't just cold air. This is persistent and brutally cold air that's been building up for a long period of time. This cold air mass isn't moving on its own. It's parked over central and western Canada, and it's acting like an icebox. Every time a storm system dips south into the US, it pulls some of that cold air with it. And because the reservoir is so large, it doesn't run out. It just keeps feeding cold air into the system. What makes this particularly dangerous is that the cold air is unusually dense. When the air is this cold, it's heavier, which means it sinks and spreads out. It floods into the lower latitudes, pushing the freezing line farther south than usual. Places that might normally be on the rain-snow line are suddenly well into snow territory. And here's the kicker. Even though this cold air doesn't move on its own, high-pressure systems over Canada are actually pushing it southward in waves. Each wave brings another blast of frigid air, and each blast increases the likelihood that any precipitation will fall as snow. If you've been wondering why this winter feels colder than usual, this is why. The Arctic has basically set up camp over North America, and it looks like it's not leaving anytime soon. Coastal snow machines. Alright, so we have an unlimited supply of cold air. Now we need moisture, and we do have plenty of moisture too. The atmospheric pattern right now is favoring the development of low-pressure systems along the Atlantic coast. These are called coastal lows, and they're snowmaking machines. Here's how they work. Warm, moist air from the Atlantic Ocean gets pulled into these low-pressure systems. The storm strengthens as it moves up the coast, and all that moisture gets lifted into the colder air above. As it rises, it cools, condenses, and falls as snow. The more moisture the storm can pull in, the heavier the snowfall. And right now, the Atlantic is basically an open faucet. Sea surface temperatures are relatively warm, which means there's a lot of evaporation happening. That moisture gets funneled into these coastal storms, supercharging them. This is why some coastal cities are seeing such heavy snowfall. They're right in the path of these moisture-laden systems. And it's not just one storm, it's a parade of them. One system moves through, drops a foot of snow, and then a few days later, another one comes. The pattern is stuck, and it keeps repeating. What's especially interesting is that these systems are intensifying rapidly. This is called bombogenesis. And when that happens, you get explosive snowfall rates of 2 to 4 inches per hour. That's the kind of snow that shuts down cities. Blocking pattern. So we've got cold air, moisture, and coastal storms. But why isn't this pattern moving on? Why is it sticking around for so long? The answer is blocking. High up in the atmosphere, over places like Greenland and the North Atlantic, there are massive high-pressure systems that aren't moving. As if they have nothing better to do, they're just sitting there, blocking the normal flow of weather systems. This is called a high-latitude block, and it's one of the most important factors in this whole setup. Normally, weather systems move from west to east, pushed along by the jet stream, but when a block sets up, it acts like a wall. Weather systems can't move around it easily, so they slow down or stall, and when they stall, they dump more snow. Imagine being outside, desperately needing to use the bathroom, but some people are deliberately blocking the door and refusing to move. No matter how much you try to reason with them, they won't step aside, and you have no choice but to... Right now, the blocking is incredibly strong. It's forcing the jet stream to bend and buckle, creating deep troughs and sharp ridges. This amplifies the weather. Cold air digs deeper into the south, storms move slower and drop more precipitation, and because the block isn't moving, the pattern just repeats over and over. This is why some regions are seeing record snowfall totals. Jet stream shift. Finally, let's talk about the jet stream itself. This is the river of fast-moving air that flows around the planet at high altitudes. It's what steers weather systems, and right now, it's doing something unusual. The trough in the jet stream is getting sharper, and that's when winter storms become more powerful. But there's another factor at play. The trough is also turning negative. A neutral trough is aligned roughly north to south, while a negative trough tilts from northwest to southeast, and that tilt changes everything. When a trough goes negative, it increases the amount of spin in the atmosphere. This spin, or vorticity, is what drives storm development. More spin means stronger storms, and stronger storms mean more snow. Negative tilted troughs are also more efficient at pulling cold air southward. They act like a funnel, channeling Arctic air down into the lower latitudes. At the same time, they're lifting warm, moist air from the south. This creates a powerful contrast, and that contrast is what fuels heavy snowfall. What we're seeing right now is a jet stream configuration that's almost ideal for producing major winter storms. And as long as the jet stream maintains this configuration, the snowfall totals will keep rising. It's not just one factor, it's all of them working together, and the models are showing it. Unless something breaks that pattern, the snow is going to keep piling up. If you liked this video, don't forget to subscribe. I'll see you in the next video.